As we go to form a conclusion, everything is about the relationship between the test statistic and the critical values. So what you're comparing your critical value and your test statistic, right? So probably you should write that out since it's so new. You're going to compare your critical value, or you might have two of them like we saw, and your test statistic to compare them. What you want to be is far away. Your goal is to reject the null hypothesis. You can do that. So I'll put you can reject the null hypothesis if you are more than the critical value away from center. So let's play the what if game. So what if you had some data and you were trying to test this claim? The claim that P is less than 70%. Well, the null hypothesis would be P is equal to 70%. You'd love to be able to say that it's definitely not going to be 70%. Because if it's not going to be 70%, then you're to one side. And what side would you be on? The side where your data is on. And so the alternate hypothesis is the same since it has that symbol. So let's suppose you did the third step and the test statistic was something like negative 2.38. If you did your critical value, let's suppose we did our critical value and the critical value was negative 1.645. What would have come out if we had a 0.05 level of significance? We would have had a critical value of 1.645 like we saw in the last video. So you are only going to reject the null hypothesis, which is our goal, if you are more than the critical value away from center. So where is our value? Whatever the sample value was, it was 2.38 standard deviations below. Well, you're going to reject the null hypothesis if this is more than 1.645 below. So the question is this value in the tail? Right? So there's a tail that's created. And is that value in the tail? Well, remember, the z value that's right in the center is 0. Now, I know that, let me put it in a different color. We're picturing 0.70 in the middle, but that's a p. Remember what we have right now. We have z-scores, so we're subbing everybody out for a z-score. That's a z-score. This is a z-score. So this is 0. So 0 is right in the middle. Then we get to something like negative 1, negative 1.645, right? And where is negative 2.38? Are you okay seeing that negative 2.38 is out here? It's in the tail. It's beyond 1.645. It's more to the left than negative 1.645. And therefore, we accomplish our goal. We're going to reject the null hypothesis. Well, that says a lot. If you reject the fact that it could be 70%, then it's not 70%, and we know what side it's on. We're seeing it come in on the side less than 0.70, or we would have never made that claim. So whenever you reject, you're going to be able to write a statement about the claim. And this is the statement: there is sufficient evidence to support the claim that the percentage in the population is less than 70%. That's what it feels like when you do a whole problem. Is it feels like, oh, there you reject the null hypothesis, and then you're able to say, hey, you know what, there is sufficient evidence. There's going to be times, though, that you're not going to be able to reject the null hypothesis. If you remember one of our earlier examples, we made the claim that the percentage of students that like the transition to online is greater than 65%. Our null hypothesis was equal to 65. Our alternate was the same as the claim because the claim had an alternate type of symbol. And so we did our test statistic and found out that it was 0.33. We found a critical value, and it was 1.645 because we had 0.05 up there and we just looked that up. Well, where is 0.33 on the z-score scale? Well, z-score 0 is in the middle. That's just right here. We're not out here we're not in this tail area. This is where we wanted to be. So because we're too close to center, we're going to fail at our goal. And we're going to fail to reject the null hypothesis. And so whenever you fail to reject the null hypothesis, the statement is the same. There is not sufficient evidence. Sometimes they'll say it like this: at the 0.05 level of significance. I think more often than not they'll throw that statement in there so everybody knows where they tested it at. To reject the null hypothesis of p being equal to 0.65. So because we can't reject that, we don't know that we're above it, we don't know if we'll be it, and we don't know if we'll be below it. We pretty much know nothing. And so some books will say it like this: there is not sufficient evidence at the 0.05 level of significance to reject that null hypothesis. And so this is the way our book is wording it: there is not sufficient evidence to warrant rejection of the claim that half of us say we should replace passwords with binary. So I'm just reading an example in there. So we'll see what they're writing in the book. This is sufficient, but I want you to remember, when you fail to reject, you're saying, okay, you're seeing it happen, but there's not enough evidence to know that that's going to happen overall. But when you have a strong case, when you're beyond that critical value, you can make a very strong statement. There is evidence to support the claim. And that's how these problems will end, with statements just like that. How many times? Every single time you're doing a full problem from 8.2 or 8.3.